In this video, we will learn about lifting state up with TypeScript. Let's first understand why lift state up. When two or more components need to share or synchronize data, keeping separate copies of state in each child causes bugs, drift, double updates. For this, the solution is move to the state to their closest common ancestor and pass data down as prop, intent up via callback props. This gives you a single source of truth and predictable rendering. Let's see an example of lifting state up parent and child input. First, import React and use state hook. We will keep the actual state in the parent component. Then define the prop types for the child. It will receive a value to display and on change callback to report edits. The child does not own state. It simply mirrors props and erases changes. Declare the child component. We destructure value and on change from props and enforce the child props type. Render a controlled input. Its value comes from the parent via props. On every keystroke, we call the parent's on change with the current e.target.value. The child remains stateless and reusable. Export default function parent. Declare the parent component. It will own the single source of truth. Create local state text in the parent typed as a string initialized to empty string. Set text will update it. Start returning the UI. Wrapper element to group the child and mirrored output. Render the child with two props. Value is equal to text in the braces passes the current parent state down. On change is equal to set text in the braces wires the child's edit straight into the parent state updater. This is the key lifted state pattern. Data flows down. Intent flows up. Display the current state so users see changes immediately. Whenever text updates, this re-renders. Close the wrapper, the return and the component. We now have a parent as a single source of truth and the dumb child input that reports changes. If you want to be explicit with the event typing in the child, you can write on change is equal to e::react.change event HTML input element arrow mark on change e.target.value. This pattern prevents duplicated state in siblings and keeps UI consistent by lifting the state to the nearest common ancestor. Now we will see a classic case study example, temperature converter. Our goal is to give two inputs, Celsius and Fahrenheit, should always stay in sync. If each input kept its own state, they would get out of sync. We lift the state to the parent. Utility functions, pure testable. These are the utility functions. Temperature input, a reusable child. First, we will import React since we are creating a functional component. Define a TypeScript union type called scale. It can be either C for Celsius or F for Fahrenheit. This prevents invalid values. Here we create an object called scale labels. The type records scale, string means the keys must be C or F and each maps to a string. This lets us display a friendly label depending on which scale we are using. This defines the props our component will receive. Scale tells us whether this input is Celsius or Fahrenheit. Value is the current value controlled by the parent. On change, a callback that reports edits back to the parent. Then define the temperature input component. We destructure scale, value and on change from the props and enforce the temperature input props type. Now we render the input field. First we show the correct label either Celsius or Fahrenheit using the scale labels scale. The input is fully controlled by the value prop from the parent. When the user types, we call on change with the new text, sending it back to the parent. The placeholder also changes dynamically, showing enter Celsius or enter Fahrenheit depending on the scale. Close the component function. This component does not hold any state of its own. It simply receives state and reports change backup. That's make it reusable and perfect for lifting the state up to a parent container. This component is deliberately kept stateless. The parent decides what the value should be and this child just renders it. That's the key pattern in React. Children are dumb presenters while parents hold the single source of truth. Now let's see one more example where parent owns the single source of truth. First import React and the use state hook which we will use to manage the shared state. We import the child component temperature input. Each child will represent one temperature scale, Celsius or Fahrenheit. We import three utility functions. TOC converts Fahrenheit to Celsius, TOF converts Celsius to Fahrenheit and Try pass number safely passes a string into a number. Then define a union type scale which can only be C for Celsius or F for Fahrenheit. This prevents invalid values for scale. Declare and export the main parent component temperature converter. Create two pieces of state. Scale keeps track of which input was last edited, either Celsius or Fahrenheit. Value stores the raw text typed into that input. Together, these form a single source of truth. This handler runs when the Celsius input changes. It sets the current scale to C and updates the raw value to the whatever the user typed. And this handler does the same for Fahrenheit input, set the scale to F and update the raw text value. Here we calculate what should be displayed in the Celsius input. If the last edited scale was Celsius, we just use the raw value. If the last edited scale was Fahrenheit, we convert that value into the Celsius using TOC. If parsing fails, we show an empty string, otherwise we display the rounded converted value. We do the same for Fahrenheit. If Fahrenheit was last edited, display the raw text. If Celsius was last edited, convert that into Fahrenheit using TOF. Again, return empty if parsing fails, otherwise show the rounded conversion. This is an extra derived value. We check the Celsius number. If it's invalid, show nothing. If it's 100 or higher, say water would boil. Otherwise, say water would not boil. Here's the JSX. We render a heading, then a Celsius input, passing in its current value and the Celsius change handler, then a Fahrenheit input, passing in its value and the Fahrenheit change handler. Finally, we display the verdict message about whether water boils at this temperature. We close the component. The parent now owns the single source of truth, keeping Celsius and Fahrenheit inputs perfectly in sync. This is the classic example of lifting state up instead of each input holding its own state. The parent manages everything. The children just display values and report changes. This way, both inputs always stay synchronized. Some of the key ideas: single source of truth, scale value tracked by parent, no duplicate state, sibling value is derived at render time, children are dumb or presentational, they receive value and report on change. Next, we will see an example multi-child form sibling sharing state. First, import React along with two hooks, use state for managing filter state and use memo to efficiently compute filtered products. Then define a product type. Each product has an ID, a name, a price, and an in-stock boolean. Create a simple product list. Each object matches the product type. Define the shape of our filters. Query for search text only in stock as a checkbox filter. Max price, which can be a number or an empty string if not set. This is the filters component. It's a controlled component. Value holds the current filter state. On change reports update back to the parent. Here we define a reusable update helper. It takes a key like query or max price and a new value. It creates a new filter object with the updated field and calls on change. This ensures filters are always updated immutably. This is the filter form, the first input for searching by name. The checkbox toggles the in-stock filter. The number input sets a maximum price. All three are controlled by the value and update through our update helper. This is the product list component. It receives an array of products as props. If the array is empty, it shows no results. Otherwise, it renders a list with each product's name, price, and stock status. Define the parent component catalog. This is where the state lives. Then create a state for filters typed as filter state. Initially, the query is empty, the checkbox is false, and max price is blank. Here we compute the filter product list. We use the use memo so it only recalculates when filters change. If only in stock is true, we exclude the out of stock products. If max price is set, we exclude products above that price. If a search query exists, we only include items whose names match. This derived list is our actual data for display. In the JSX, we show a heading. We render the filters component passing in the current filter state and the updater function. We render the product list passing in the filtered products. This way, the parent owns the single source of truth and both children stay in sync. We close the catalog component, the entire filter and list pattern is complete. This is real world case of lifting state up. The filter state lives in the parent, while filters and product list are sibling components. By lifting state up, both siblings stay consistent without duplicating logic. Parent catalog owns all filter state. Filter and product list are siblings that stay in sync. Group parent state. Derived data computed with use memo from the single source of truth.